Alright, in this video we're going to be going over elasticity. And what elasticity is how responsive demand or supply is to a price change. And the purpose of elasticity in economics is that they use this to see how goods or services are affected by price, and to the extent of which they are elastic or not. Like for example, something might seem inelastic at first, like bread or something like that. So they're trying to see the extent of bread's elasticity. So like if you jack up the price of bread a whole lot, then maybe people will stop buying bread, and that's how the demand is being affected by price change. And you can think of elasticity as like a rubber band. If you have like a really thin rubber band, then it could be stretched really easily. It's quite elastic, and it could stretch really far. But if you have a really thick rubber band, then it's a lot harder to stretch. So it's more like inelastic. So elasticity is also termed as a value. When something is elastic, that is when its value of elasticity is greater than 1, and if it's inelastic, its value is less than 1. So and for the graph, the elastic graph will look very horizontal, while the inelastic graph will look quite vertical. And you can imagine this as like a rubber band. When a rubber band is stretched out, it's like really elastic, but when it's inelastic, it's kind of stays in its rubber band form. Maybe it'll stretch out a little bit. So yeah, this is kind of like, there's also other types of elasticity as well. There's something called unit elastic. That is like a 1-to-1 ratio. So a 1% increase in price would increase demand or supply by 1%. There's also perfectly elastic. That is when even just a little price change would affect the elasticity a whole lot. That is when that's basically when the graph is horizontal. So even if the price changes just a little bit, it increases the supply or demand very drastically. And there's another one called perfectly inelastic. This is when no matter the price change, the quantity demanded or supplied is still pretty much the same. That's pretty much just a horizontal. That's pretty much just a vertical line. And yeah, those are the main different types. Those are the main types of elasticity. So how do we find elasticity, the value? Well, I mentioned this a bit before, but you find it with a ratio of the percentage change in demand or supply over the percentage change in price. Alright, there's also something else to point out. Usually in a demand curve, the law of demand, when you increase the price, you decrease the demand. So in an elasticity equation, when it's the percent change in demand over the percent change in price, then in this, let's use this example over here. Then the price increase would mean that there's a negative demand um, in the numerator because there's a decrease in demand. So what this value would end up, so what you'll end up with is a negative elasticity for demand. But if you when you're but usually you just use the absolute value when you're finding the elasticity of the demand. Then you just end up with a positive value because it's you just take the absolute value. However, this when comparing, there's a different scenario that happens when you need the sign, whether it's positive or negative. But I'm gonna talk about that later. I'm gonna but that situation but I'm gonna get back to that situation in a bit. Now I'm also gonna talk about total revenue and how total revenue plays in this picture. This is the amount of profit you get from this type of stuff. And what we do with total revenue in terms of economics is to see how it responds to price changes for a certain object depending on its elasticity. So let's give two scenarios. Let's say that the elasticity is inelastic. This is when the price doesn't affect the quantity demanded or supplied. So what you could do is test the elasticity. So you could just jack up the price as much as you can, and that will result in an increase in total revenue. So for example, if you're selling bread, and you can see how if you increase the price by like $1 or something, let's say that given that bread is inelastic, if you increase the price by like $1 or something, then and the demand is still the same, then your total revenue would increase as well, depending on how much bread you sell. And let's say you increase it again by, I don't know, like $10 or something, then and the quantity demanded, and people still are gonna buy that bread as well, and then your total revenue increase even more. So here's like a visual for it. Say this is a rubber band, um, and let's say that this is a price decrease and a price increase. So when it is inelastic, when you increase the price, then the total revenue increases with it. Like if you can't stretch a rubber band if you're pulling one side and another side in the same direction. So let's take a look at what happens if the object is elastic. When it's elastic, the price does affect the revenue. So in this case, for example, if you're trying to stretch up the price and you're trying to increase the price, then people don't want to buy it anymore, because when people buy stuff, that's like that's the demand. So when you increase the price, according to the law of demand, you lose demand, and in return, that will lose total revenue. So, like let's say for example, you're selling like let's say you're selling like a smartphone, and you increase the price by like $50. Well, there are like other Samsung, there's like other smartphone competitors out there that have a cheaper price than your smartphone. So less people will buy your smartphone and your revenue decreases. So what you can see here is for a visual, it's still gonna be negative and positive. And when it's elastic, the you can say like this rubber band would go out this way. It'll be a lot wider because it's elastic. So when the price increases, then the total revenue goes the other way. We have to label this as price, this is total revenue. And up here this is price, and this is total revenue. So yeah. And looking at this conceptually, if the price increases and it's an elastic thing, that means that less people are gonna buy it, because I think like when something is more elastic, it's like if the it's like the demand would okay, so when because this happens because when something is elastic, the demand heavily is um is super responsive to the price. So if people don't want to buy, if the price changes just by a little bit, then it would. So if the price increases by a little bit, then people will go find something else to buy, or like yeah, they'll find something else. Yep. Like in this example. All right, let's do an example to show how you find the elasticity of an object. So I'm just gonna write out the. So let's say that a certain company is selling markers. It increases the price of one marker from $1 to $2. And this results in a supply increase from 10. This is a really small company, so let's say like 10 markers to 15 markers. And what we're trying to find is the elasticity of these specific markers. So I'm gonna write the formula out, and yeah. Alright, so this is the formula, and what we could do here is we could start off with, and because I'm using supplied because the question has values for the supplied schedule. So what we could do here is we could start by finding the percent change in the quantity supplied first. So if you remember the formula, it would be new minus original over the midpoint times 100%. So what we could do here is we could substitute in the values. So we can see that how the value increased from 10 to 15 markers in the supply. So the new value is 15 minus 10, the original, and the midpoint would be 12.5, and this all would be times 100%. And what this will result to is a 40% increase. And this would be the percent change in quantity supplied. Now let's find the percent change in price. This would be from $1 to $2. So the new would be $2 minus the original, which is 1, over the midpoint, which is the average between these two values, which would be 1.5. You can find this by adding 2 plus 1, which is 3, and dividing it by 2, which is 1.5. And you multiply that by 100%, and the value you end up with is 66.67% increase. And now that we found the quantity supplied and the price in their percentage changes, we could plug them into the formula to get our elasticity value. So let's do that here. It'll be 40% over 66.67%, and that will result us in a value of 0.6. So this will be the elasticity of the marker company, and this would be the elasticity of the markers in the marker company. And because this is less than 1, the markers are inelastic. Alright, so let's go back to the topic of substitutes. Let's recall that a substitute is something that is a replacement or something that's very similar to an object. This could be like let's see. This could be like a pizza or a burger. While a complement is something that goes along with the object, like pizza and a soda. So, but then you could tell what these things are based off of just like what you know about the world. Because usually but then let's take a look at it. Let's say you don't know if one object is a substitute or a complement to another. You could use elasticity to figure out whether the object is a substitute or a complement. And what we use here is called the cross elasticity of demand. And what this does is that it compares the quantity of a good with the price of a substitute or a complement. And this is the formula. So before I give an example, let's just break down the logic behind this. So usually when the price of a substitute increases, then the demand of the actual object increases as well. So say for example the price of a burger increases. Because the burger is a lot more expensive, then then more people will buy pizza, which is a lot cheaper. So then the demand of pizza would increase. In this case, the price of the substitute and the quantity demanded are both going in the same direction. So if it's positive, if there's like an increased price change, then there's an increased demand. And vice versa if it's negative. So, and because a negative over a negative cancels out, if the cross elasticity of demand is a positive value, then the two objects in comparison are substitutes. This is when plus or minus signs matter in demand. Now let's take a look at a complement. So this example has complements that are given, but we can have an example where we prove that this is a complement or a substitute. So in this case, with the price of a soda increases, then people aren't really going to buy soda anymore, because according to the law of demand, if the price of the soda increases, then the demand of soda decreases. And because people usually buy pizza with soda, if people stop buying soda, the demand of pizza will be negatively affected as well. So if the price of soda increases, then the demand of pizza decreases. So you can see, if there's a price increase, a positive in soda, there's a negative demand, a decrease in pizza. And if we do it vice versa, if there's a negative price of, and that works the same way vice versa as well. So what you can see here is there's a positive and a negative for a scenario, and a negative for each scenario. And when you put this in the equation, if there's only one negative in there, you're going to result with a negative elasticity. And when there's negative elasticity, that means that it is a complement. Let's do an example for the cross elasticity of demand. So let's say that there is a price decrease for a mouse from $15 to $10, and there's an increase in demand, for a laptop from 300 to 400. So now our goal is to find whether or not a mouse and laptop are substitutes or complements. Now you may know already whether they are substitutes, whether they are substitutes or complements, but elasticity proves that why they are substitutes or complements based off of the stats we have right here. So the formula would be the percent change in demand, or the quantity demanded, because in this case we're talking about demand, over the percent change in the price of the other object. It could be a substitute or a complement. I'm just gonna abbreviate it here. And let's before we start this, let's find the percent change in demand. So using the formula, given a go, it's new. I'll write over here. New minus original over midpoint times 100%. So the new value for the laptop demand is 400 minus the original, which is 300, and the midpoint is the value that's in between them, which is also the average, which is 350. Now we multiply this by 100%. And simplifying this, I solved it ahead of time. This is 28.6% rounded to the nearest tenth. And that's the percent change in demand. And this is a percent increase because it went from 300 to 400. But in this case, because we're dealing with absolute value, it doesn't really. Actually, no. In this case, it does. In this case, it does matter whether it's positive or negative. And because it's from 300 to 400, then this is a positive value, as we can see here. So let's take a look at the price change. So it went from 15 to 10. So the new one is so the new price is 10 minus the original, which is 15, and the midpoint, the average for these two values, would be 12.5 times 100%, and what this would give us is 5 over 12.5 times 100%, which is 40%, or negative 40%. And what we can see here is that this is a negative value, so we can we can already tell whether or not this is a substitute or a complement because of the different signs. But let's just follow this. Let's just follow through with this. So now that we have the two percent changes, the demand and the price change and the price, so let's find the elasticity of it. So it'll be 28.6% over negative 40%, and that would result in negative that will result in an elasticity of value of negative 0.71. So normally elasticity values are positive, but in this case we're trying to figure out whether it's a substitute or a complement. And in this case, because it's a negative, then it is a complement. And also, just on a side note, like I said before, if it's a negative 40%, it could also be the same thing as a 40% decrease, while a positive would be an increase. So this would be 28.6% increase. Now let's take a look at a different type of elasticity. This will be the final one we're going to go over in this video. It is the income elasticity of demand. And this is how responsive the demand of a good is based off of the income change. So, and the formula for this would be the percent change in demand over the percent change in income. And what this finds is, and this determines whether something is a normal good or an inferior good. So a normal good is when when the income increases, the demand for this good increases as well. Like for example, the newest smartphone. If you have an increased amount of good, if you have an increase in income, then you'll have a greater demand for this good. And the other option is the inferior good. This is when you increase. This is when you get an income increase. You have a decrease in demand for this. Like for example, you're no longer, I don't know, like a broke college student, so you no longer have to buy canned food when you got into a job, when you, or like, yeah, when you get when you get a job that pays you like 50K a year or something like that. Or not even 50K. When and this happens when you and this happens when you have like when you're making like six figures right off of college or something like that. You don't have to pay for canned food no more. And like the substitute or complement type of problem, you determine whether something is a normal good or an inferior good based off of the based off of whether the value you get is positive or negative. So if the value is positive, then it is a normal good. But if it is, because these two go the same way, so it's either positive and positive or negative and negative. But you can tell if it's an inferior good if the income elasticity of demand is negative, because the possible values could be positive and negative or negative and positive. And yeah.